This is the 6th year that the Young Software Engineer of the Year Award has been sponsored by Skills Development Scotland. And as the newly appointed chair of the Digital Technology Skills Group, I'm really honoured to have the opportunity to present this award. Young people with vision, passion and new-to-world ideas are particularly needed now more than ever as we face this changing future. In my humble opinion, no award epitomises this more so than the SDS Young Software Engineer of the Year Award. Previous winners have gone on to bigger and better things in the world of software development, and deservedly so. Tonight's finalists deserve recognition for their hard work, their drive and their go-get-it attitude, and I congratulate them for making it to the final. Now let's see who the winner is.
My name is Conrad. I've been studying at the University of Aberdeen for 5 years now. My project was concerning enhancing the transparency of data and data privacy. My project was about IoT, such as smart speaker, smart temperature sensors. The idea is that all those sensors are sending data back to one centralized structure. We don't know where the data is going to, we don't know what's going to happen with it. With the increased consciousness of protecting this private information for everyone, I had to come up with a solution which will allow us to audit this information and make sure that it doesn't end up in the wrong hands. Prior to starting my project, I was involved as a research assistant in my computing science department at university, working in a separate project, but also involving blockchain plus IoT sensors. This project was slightly different. It was tracking of the food deliveries across Scotland and ensure that temperature is compliant. I was heavily involved in the IoT sensor world, and since we also use blockchain to store this information, and I really wanted to reuse this knowledge one step further, we want to make sure that the data captured by those temperature sensors is secure. By putting the IoT data, who access this information on blockchain, I'm able to verify that the information that the people are accessing are only the people that could access that. There's also a way to monetize this. You deploy a smart meter in your house, people will be able to pay you money to access the information from your house. Overall, the popularity of those IoT sensors, there's probably one on the bus stop, even some in the medical usage, smart heart rate sensors, which will alert the emergency services if you're falling into cardiac arrest. Nobody really thought about securing this data. Privacy is very, very important, and people are sometimes not aware about the amount of devices they have in their house. Like, even myself, I have like 2 different smart assistants in my house. I'm trusting they are not being sent to any wrong places. But by putting this information on this distributed blockchain, everybody can verify and make sure that the data is used in the correct way. After the dissertation was handed in, it was found to be quite interesting by my university supervisors. Hopefully this work will be published somewhere in the academically recognized journal, maybe later this year or maybe next year.
I'm Brian. I went to the University of St Andrews, and my project is about the safety of software. There was a real missing area that I thought was an opportunity to try and push the boundary a little bit, and I thought that was quite exciting. We have these existing tools which already work, they're already used in industry, and then we have these research level problems that still have not made it to industry, which is where we get this problem where you can verify an algorithm but then it still crashes. And what I really wanted to do was try and push some of that good research level stuff into some more practical area, so that someone who's maybe familiar with an existing tool could benefit from all this research. Anytime you have multiple things working independently and they've got to communicate in some way, it's about that communication. Multiple computers running in parallel, trying to send messages, they're trying to communicate, they're trying to make sure that they all have a consistent view of the world. If any one of them trips up, that could spell disaster. We did logic and software verification, which is a basic module covering the groundworks of verifying safety in software. Through my own research and talking to my supervisor, I learned of this missing piece of the puzzle, that a lot of the tools and research that was current was a bit naive. So this is as simple as 4 lines of code running on 2 separate processes. The way we think about this as software engineers, what possible order could these lines execute in? But actually, this way of thinking about interleavings is fundamentally flawed when you're talking about code running on a modern computer. Looking at this, you will miss some of the possible unsafe behaviours. Even the software that's used in industry now is making these same flawed assumptions. The whole motivation behind the project was to try and take all this good research on the complex ways that programs and computers can behave and to try and build that into a tool that your everyday programmer could use. In the industry of software development, these formal methods, these complicated tools, they have a certain barrier to entry. And so my project is about trying to capture the really complicated, nuanced behavior that happens when you have multiple systems interacting. So you can take a description of the system that you've made, you can input it into the project I built, and it will give you thumbs up, thumbs down, yes it works, does what it says it does, or no, you want to check this edge case here. And hopefully that means we'll have less buggy software in the world. Everyone, whenever they want to step on a plane or have a medical device implanted, would very much agree that that is something we want to see more of in the world.
My name is Danielle. I came here 4 years ago to do a computing science degree in Glasgow Uni. My project is called a deep learning approach to artifact correction for photographic film. I've been shooting film for 6 or 7 years. It's been my hobby. As I was doing my computing degree, one of the modules that I got to do was computer vision. There's a lot of research happening around neural networks, deepfakes, things like that. I thought I could combine it with my hobby to do something useful for people like me that shoot film, but also people who restore old media. Currently, when people restore film or old photos, they will take the photo and someone will manually select the dust to being painted and fixed. That can take a lot of time, especially if you're fixing an entire roll of film stock for an old movie, for example. My attempt was to use neural networks to automate that process to help media become more readily available for people to see online or in museums. I approached the computer vision lecturer, Dr. Siebert, to supervise my project. It all just went from there. He turned out to be also quite passionate about old cameras. The main things that we did was collect old photos of all around America. The idea of it was that in the future people will be able to see what the world was like before environmental damage. To teach a network like that to correct, you need to show examples of both damaged photos and good-looking, clear, natural photos. The way I went around that was to take photos that are already clean, add dust and scratches to them, and then I can show both to the network, and over time it can learn, needs to remove the scratches. I'm working as a software developer now. I'll be going back to uni in a few months to do a PhD, which extends my project. Besides the practical application of my work, which could be used to make film or photo restoration much quicker and cheaper, it also has implications in larger research topics. I didn't expect my project to go so well. I didn't expect it to actually be able to remove dust and scratches as it did towards the end. My supervisor was very happy with it. He was very interested in continuing the work and doing a PhD. I thought, why not? It's a great opportunity.
My name's Craig Perry. I studied software development and computing science at RGU. The project is using state-of-the-art computing and AI vision techniques, basically training a computer to understand what corrosion looks like in underwater environments. I knew I wanted to do a project around computer vision and AI because that was where my interests lay. I did a work experience program with the oil company last year. It was them that actually expressed interest in that project. They said it would be very valuable for them. The project itself is very much more a data science project than a software development project. I had to research computer vision techniques and state-of-the-art algorithms such as CNN, which is just for classification. That's just basically saying there either is or there isn't rust in an image. And then you've got the object detection method, YOLO. It's got a payoff between accuracy and speed. YOLO is very fast, but it's not very accurate. This is the most interesting of all of them. This is the one that I'd use if I took it to industry. Still got the bounding box, but it breaks it down even further and highlights the pixel perfect outline of where the exact object of rust is. A corrosion engineer should just be able to get a picture or a printout and be like, okay, there's corrosion here, I need to treat it with this, I need to spend this amount of time and resources on it. Hopefully it would speed up the job a lot more. It was very exciting. I knew I wanted to have something that would actually have a real world impact, and to have something that I could continue afterwards is really exciting. Yeah. $2.5 trillion per year is spent or lost because of corrosion. If you can speed up that process of identifying corrosion or make it more efficient, any tool that can be utilised to just make that process better will be accepted by the community. You're saving the industry trillions. Next, I'm going to be doing a Masters in Data Science, learning more about that sort of thing, potentially continue that into a PhD. The success I've had with that project has definitely motivated me to study another year. There was a group of 3 people that approached me as part of RG Startup Accelerator. My academic supervisor had linked me up with them and said that we might be able to help each other out. Our goals aligned very well, and I became a business partner with them. There's a lot of companies that are willing to work with us. There is a lot of client interest and excitement in the industry for it, actually.